Hi everyone, welcome to our Endeavour presentation video. I'm team leader Zanjie. This video will show you what our project is and how our project contributes to innovation in the field of infrastructure engineering. Now, please let me briefly introduce our project. The 3D concrete printing technology is rapidly developing in recent years in construction fields for its high freedom of design, high predictability, and speed of delivery, and great sustainability. In the construction industry, the concrete 3D printing technique is referred to as the process of placing a continuous filament of cement-based concrete through a small nozzle, mounted on a robotic arm in order to build a vertical standing multi-layer product. Our capstone project is to analyze the principle of 3D CP and to provide a structured insight into the technical issues and solutions surrounding 3D CP. We will discuss the properties of fresh materials used in 3D CP prior to salt setting, pumpability and buildability, and hardened properties of 3D CP materials, as well as the applications of 3D printed concrete in modern society. The outcome of the project will be a well-developed 3D printing mixture by considering general design principles for 3D printing of concrete material. Now, Kai will introduce the benefits of our project.
Thanks. So the 3D concrete printing could be a new solution to the construction industry. As a viable new production process, 3D concrete printing can introduce a great geometric freedom into the design process, as well as offer a noble meaning of manufacture that could avoid the need of mass production of identical concrete parts with limited number of variants. Hence, it reduced the material waste. In terms of resource consumption, more than 40% of raw material used globally are consumed in the construction industry. According to the research, it accounts for a significant amount of harmful emissions, and this activity generates a large amount of solid waste. The 3D printing could be the solution to this problem, as construction machines used are fully electric, which means it is almost emission-free. In addition, 3D concrete printing is able to complete the construction of an entire house in less than 2 days, instead of several months. This speed of operation results in efficiency of construction logistic and management, and hence it results a positive impact in both transportation system and the environment. Now, Julian will talk about our findings.
Thanks. From our research, we explore the influence of different materials to several important properties of 3D printing concrete and optimal compositions of those materials. The properties include flowability, extrudability, open time, buildability, mechanical properties, and shrinkage. Wider particle size distribution and larger water-cement ratio of raw materials will enhance the flowability, while adding fibers may have opposite effects. Extrudability is similar to flowability, while the shape of particles plays a more important role. Raw materials with smooth grading, round shape, and fine particles will have better extrudability. The open time is mainly influenced by the retarders and accelerators. Buildability is related to the flowability and the open time. By adjusting the proportion of sand, fly ash, silica film, and nanoclay in raw materials, the buildability can be effectively controlled. Other chemical additives are also key to balance the buildability and other properties. Mechanical properties cover a wide range, but are mainly adjusted by the proportion of raw materials. Some optimal compositions are explored in the research. Last, increasing mineral admixtures, lowering water-cement ratio, and adding shrinkage-reducing admixture can reduce shrinkage during the printing process. Then, Shuotian will introduce the innovation.
Thanks. Well, although the 3D CP technique has developed rapidly in recent years, the application field is relatively narrow, which is mainly used in bridges or small and medium-sized buildings. Through further exploration of this project, from which can be seen that by changing the structure of material, the strength of the material can show a variety of properties so that the 3D CP technical can be used more widely. And in addition, because the technical itself is easy to operate and requires less labor, it can also be provide ideas for future applications in higher-end fields. For example, working in vacuum and even use local soil or materials on Mars and Luna to build space stations. And 3D CP also have a accuracy that is different from manual operations. Most of the construction process relies on mechanical manufacturing, so accuracy is guaranteed, which given this technical greater advantage in the construction of complex and precise building structures. Thanks. Any questions?